Hello students, welcome to the channel. Now in today's topic we are going to discuss about Bayes theorem. This is very important theorem, and to understand Bayes theorem we'll first understand what Bayes theorem actually telling. Now suppose we have two bags, bag 1 and bag 2. Bag contains some white and some red ball, other bag contains some white and some red balls. Now can I calculate the probability of selecting a bag? You can say yes sir. We have two bags, so probability of selecting any of the bag is 1 by 2. If I ask you, can you calculate the probability of taking a ball of particular color when you know from which bag it is drawn? Yes, if you know from bag 1 it is drawn, you can calculate the probability of any color. If you know the ball drawn from bag 2, you can calculate. Now the third question is, can you calculate the probability of selecting a bag when a ball of particular color is drawn? You know. Now think about this. This is just reverse. What? That's reverse probability, and that is what we need. We calculate in Bayes theorem for reverse probability. What is reverse in that? You have already taken a ball from any of the bag. Now you are calculating from which bag it is drawn after the event has occurred. Right? So this is what we are going to discuss in this theorem. We'll first understand the derivation of the theorem, and later on we will discuss the questions. Bayes theorem is discovered by John Bayes in 1763. What it actually tells, that we are going to discuss. Let E1 to En be n non-empty event which constitute a partition of sample space. This line should be clear. When I talk about partition of sample space, that simply means that all events, intersection between any two events is phi, where I is not equal to j, and E1 union E2 union E3 union dash 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 En is equal to sample space. Partition of sample space means these events are mutually exclusive and exhaustive, simply you can see, and having non-zero probabilities. Now A be any events of non-zero probability associated with it. A be any event of non-zero probability. As I am talking about here, reverse probability is there. PEI upon A is equal to PEI into PA by EI whole upon J equal to 1 to n summation PEJ into PA by EJ, right? By formula of conditional probability. That is PEI upon A. What is conditional probability? In numerator we write intersection, and denominator is the event that is written down A for this sample space. Now by multiplication theorem, can I write this PI into PA by EI whole upon PA? How I have written? By multiplication theorem. Now this probability of PA we have discussed in total probabilities, theorem of non-total probabilities, so we can write it also. Summation j equal to 1 to n PEJ into PA by EJ, and this is what the formula for Bayes theorem. Now you can see how I have written this. This I have written by theorem of total probabilities. Now, how theorem by total probabilities? I have prepared a video, previous video. You can watch that video and you can understand how P is equal to this. Whenever we have a question, we have suppose two events E1 and E2, and you are calculating the probability of E1 upon A. The formula simply PE1 into PA by E1 upon PE1 into PA by E1 plus PE2 into PA by E2. Why I have written this? Because of previous formula somehow students find it look like difficult. IJK क्या है? 2 events, then the formula will be like this. 3 events, then one more event will be here, and numerator will be calculated based on what is written. If I am writing here in place of 1 I am writing 2, then here it will be 2 and denominator will be same. So I hope you understand Bayes theorem. It will more clear when you will solve questions of Bayes theorem. One thing should be clear, it is of calculating the reverse probability. Thank you so much for watching the video.